So I want to do a natural deduction proof now that combines both propositional and predicate logic steps in the natural deduction setting. And so this is the same one that you would have seen in the lecture on combining propositional and predicate deduction rules. And so we start here with two universals on either side. And as we've seen a few times already in these, going forward with the universal, it requires a variable. And so instead you want to take a look at the conclusion down here and work backwards with the universal introduction. So this is going to introduce the variable for us. Now that we have the variable, you'll note that what we're trying to prove here, we only have sort of one stand-in variable x that we're using inside of this entire sequence. So we don't need to try and match the pattern of what's inside of predicates. Now that we have this variable, we can move forward and do our universal elimination here, requiring that variable. Now what you have is between steps 3 and 4, natural deduction proof on just propositional logic. There are no more quantifiers, no existentials, no universals, and so everything that you learned early on in the course can now be applied to this. Right? So if we take a look at step 4, the next step would be an implication introduction here. And if you take a look at the disjunction that we have, whenever you have a disjunction, you reason by cases and look at the different steps. And so we're going to do a disjunction elimination. It's saying it needs to target the right conclusion, so it's going to sort of refine the proof for us. And if you take a look at what we were doing here with this disjunction elimination, it says on one hand, not PI holds, and that's where you get this first box inside of here. And on the other hand, QI would hold. And if QI holds, you already have what it is we're trying to prove here. And so the only thing left to prove is this top spot. Now, if you take a look at this, we have both PI and not PI. And so we can do a negation elimination, derive bottom, and of course from bottom you can derive anything. And so this is our contradiction constructive way to sort of say, there's a contradiction between having both PI and not PI. And so this sort of completes the proof, but it's a very common strategy inside of these sort of predicate logic deduction proofs that you will need to do, is to try and remove those quantifiers and just remain with a propositional logic proof that you now need to do. And if you can do that, then you can rely on everything that you've learned early on in the course to sort of make that proof work. And so this completes the proof for this, and we'll see a slightly more complicated example in the next video.